Hey guys, welcome back. So today we're going to be looking at differentiation using the product rule. So we're going to be finding the derivative using a slightly different way to the chain rule or just the power rule. The product rule involves using the chain rule and the power rule, but it's combining the two methods together when we have a certain type of equation or function. So let's look at the example of y equals x cubed x plus 1 squared. Now what's different about this function to all the other functions we've looked at with the chain rule and the power rule, where we simply brought the power down, minus 1, and times, if we had a bracket, times that derivative by the inside of the bracket, if you can remember the chain rule. What's different about this one? Well, here we've actually got two parts. And we know that we've got two parts because we can see x in two different areas of this function or equation. We've got the x plus 1 squared is one part, and we've got x cubed as another part. So we know that there's two different parts because we can see that the x's are separated by brackets and powers. They're not together. When we don't have x's together and we've got brackets like this, instead of just expanding this bracket out and then differentiating all the different terms separately, if I was to expand this and times everything by x cubed, we can use the product rule, which is a shortcut, and it makes things a lot easier for us. So how do we do this with this question? Well, as I said, we've got two parts. We've got part 1 here, which we're going to call u, and we've got part 2 here, which is the whole bracket squared, which we're going to call v. So we've got u and v, part 1 and part 2. And what we're going to do is we're going to differentiate them separately. So I'm going to take u here and write, or I'm going to do it next to it, and write u equals x cubed. We can see that that is just our first part. So you get part 1 here. And then I get down here, I'm going to leave a bit of space up there. I'm going to get v equals x plus 1 squared. Now that was part 2. Now what I do is I differentiate each part. So I'm going to get u dash below it. I'm going to say, well, that equals, when we know from the power rule that we just bring that power to the front and minus 1. So we're going to get 3x squared. And we know here that we get v dash, we're going to be using the product rule here because we've got a bracket with the x inside, and we still bring the indice to the front and minus 1. We do the outside of the bracket first, and we get 2x plus 1 to the 1, which we don't have to write, times the derivative of the inside of the bracket. What's the derivative of x plus 1? Well, we know that in front of x is an invisible 1, so that's there, and we know that this 1 has no derivative. So it's simply 2x plus 1. So that's your first step, is to write out what each part is, separate them as u and v, and then do the derivative of each one. Now what's your next step? Well, what we're going to do is we're going to get the formula for what the derivative actually is when we have two parts. So we're going to write the formula here. So part 2, get the formula and remember that it is y dash equals u dash, which is the derivative of u, the first part, times the whole second part, not the derivative of it, plus v dash times u, which means we do the derivative of v, which is this bracket, times u, which is x cubed. So we're basically getting the derivative of each one at a time and timesing it by the other part, which hasn't been differentiated. And when you add those two bits together, then you get the full derivative for this whole function. So let's insert these into this equation. So number 3 is we're going to fill it in. So y dash equals, what's u dash? Well, it was 3x squared times v, which is just x plus 1 squared, plus v dash, which is 2x plus 1, times u, which is just x cubed. So you can see here I've done plus 2x plus 1 was our v dash, and we know that our u was just the first part. So I've used this equation exactly here. Okay, what's our next step? Well, our next step is just to simplify these bits where we can and then factorize. So first of all, I'm going to simplify it. And we know that this first part just stays as 3x squared, x plus 1 squared. Don't worry about expanding this bracket. We're just going to leave it as it is. Plus 2, and we know there's a times between that 2 in that bracket, and there's a times over here. So I'm going to put the 2x cubed together. What's my next step? Well, number 4 is simply to factorize. We can see here that there's some common factors which separated between this plus in these terms. What are the common factors? Well, here we can see that there is an x squared in both of them. There's an x squared that has x cubed, but that doesn't have cubed. And they both have this bracket of x plus 1. This one has x plus 1 squared, but this doesn't. So the highest common factor is just going to be the x plus 1 bracket and the x squared. No, none of these numbers, 3 and 2, have a common factor. So I pull those common factors out to get y equals x squared x plus 1. Then I do a bigger bracket, because this is our common factor here. This was the common factor. And I'm putting in this other big bracket, what we have to do to get back to each term. So x squared, x plus 1 times what gets us back to this first bit? Well, we first of all have to times it by 3. It's already got the x squared, so now we just have to add in one more x plus 1 bracket. What about the other term? Well, we have to add in a 2, and we have to add in one more x, because that only had x squared, and it already has the bracket outside, so we don't need to add that in. Great, so understand that I've just used this big square bracket to show that this whole bit out here was the common factor, and then this big bracket has everything else inside that would get us back to these two terms. And obviously our last step is going to be to simplify this bracket and then put it all together. So I'm going to do our next step up here, which is to say that y equals x squared, x plus 1. Nothing can be simplified in there, but we can simplify this other bracket. This is going to be 3x. We're going to expand this bracket here. 3x plus 3 plus 2x. So I've taken away that big bracket because I only did it because then we had smaller brackets inside. And this should be y dash here. Sorry that I haven't used y dash along this whole way. And then I'm going to simplify the inside. We've got 3x plus 2x. So our final answer will be x squared, x plus 1, 3x plus 2x is 5x plus 3. So that is your final derivative. So if you can follow those steps, get your equation, look at what two parts you have, and to know the parts, you just look at the different x parts. Where is x different? If this was a number out the front, I would not need to do the product rule because it doesn't have an x in it. But I have x cubed here, and then I have a bracket with x. So there's our two parts. We differentiate each part separately, and we write them over here, splitting them up into u and v. Once we do that, we write down our equation, and this is the rule, y dash equals u dash v plus v dash u. Dash means the derivative of, and then we insert all the information into the formula and make sure we take out all the common factors and simplify these brackets before we have our final answer. Okay guys, hope that helped. We'll look at some more examples later on. Thanks guys.